Okay, good morning. Welcome to
Math number 1085.
Math 1085. So we're doing a project that's continuing on the Christopher Wolfram example about how viruses spread through a network. And the reason I wanted to go through it again this week, and I've prepared a lot of stuff for this morning, so we won't have to sit around and wait for things, although I may have to search for them. One of the things I've become interested in the last week and seen some news articles about are something called super spreaders. So what do you think a super spreader is when it comes to a virus?
It's someone who, is infected with it and, spreads it to a lot of people and ignores whatever restrictions are put in place.
Okay, what would you think?
I mean, it could also maybe refer to a virus that has a very high, transmission rate.
Okay.
Or
yeah.
a central place that becomes infected with it.
Yeah, so it's not so much about the rules and following the rules or anything like that. It's just about someone who spreads to a lot of people. So one high-level way of thinking about how viruses spread is this concept called R0 or R0. Have you heard about that?
A little bit.
So sort of the average number of people that someone infected spreads to. But that can be a little bit misleading. Like, why would you think just looking at the average could be a little bit misleading?
I mean, you could have people who interact with less than that amount of people, and you could have people who interact with a lot more than that average, which could, affect the distribution in the certain area around those people.
Yeah, so you could, for example, if you had, if it was 2 and you had 100 people, so on average they would spread to 200. But what you could have, and I mean my numbers weren't matched perfectly, but you could have 99 of them spread only to 1, and then 1 person spread to 100, or I guess 101. And that would be, those would both have an average of 2. And so what we're going to look at today is we're going to remind ourselves about how viruses spread through a network, and then we're going to look at some different cases. What do you remember about how viruses spread through the network, through a network from last week?
Well, just by looking at this simulation, I think a few people start infected with it, and then whoever they're connected to, they have a 50% chance of, or some chance of spreading it to them, and eventually after a certain amount of time, the people become uninfected.
Okay, so for our graph, now this is going to be where I have to go spend a lot of time finding where I put these animations, but we have 1,000 nodes. I think someone was connected to 10 people on average. I think that's what that 5 means. And then based on, sorry, let's just get down to it. Based on the average number of meetings per step, the virus may or may not spread. So we have 1,000 people. Everyone's connected to 10. I think that's right. And we start with 10 people infected in the beginning. And this time, on average, every step somebody meets 0.15 people. So on average, it takes 7 steps for one person to meet someone else.
Okay.
And then let's get to the point where things start to show up. The blue is the number of infected, green is the number of people who are recovered, and orange is susceptible. So what we see is right around 0.25, things start to change pretty quickly. So you go from almost no one being infected, even at 0.2, hardly anybody gets infected. But around 0.25, lots of people start to get infected.
It drops pretty quickly.
And by 0.3, basically, everybody's getting infected. So it's pretty sensitive to how many people you meet. And we're going to spend today looking at that sensitivity. And then we're going to look at the super spreader concept by not doing a complicated model, but just by changing the number of people who were infected in the beginning. Okay?
All right.
All right.